Hello, this is Tony Hiller from RealClimateScience.com, setting the record straight about climate. This is part 3 of a 3-part series showing how the National Oceanic and Atmospheric Administration alters U.S. temperatures. In part 1 of this series, I showed how government agencies have altered the U.S. temperature data dramatically over the past 20 years. By altering the data, they've turned a long-term cooling trend into a warming trend. In part 2, I showed the hockey stick of data alterations which are being made by the National Oceanic and Atmospheric Administration. Older U.S. temperatures are cooled by about 1 degree Fahrenheit, and recent temperatures are warmed by about the same amount. This creates about 2 degrees of fake warming, which doesn't actually exist in the measured temperature record. I also showed you in part 2 how the data is being altered precisely to match the increase in carbon dioxide. This is a real smoking gun of scientific malfeasance. The data is being altered to match the theory rather than the other way around. In this video, I'm going to look at the adjustments in more detail. The National Oceanic and Atmospheric Administration, NOAA, releases 3 temperature datasets for the United States Historical Climatology Network. The vast majority of the official U.S. temperature record comes from this collection of data. NOAA releases 3 different monthly temperature datasets from the United States Historical Climatology Network. The 3 datasets are the raw data, which is the actual measured thermometer data. Then they have the time of observation bias adjusted data and the final adjusted data. The red line shows the time of observation bias adjustment, which I'll be discussing in more detail in a minute. The yellow line shows the additional adjustments being made to produce the final adjustment. The blue line is what I already showed you, which is the total adjustments being made. These graphs are for the average temperature data, which is the average of the minimum and the maximum temperatures. For purposes of simplicity, I'm going to focus on maximum temperatures only for the rest of the discussion. I'm also going to focus primarily on temperatures after the year 1905 because the data before that is not as good. All of these graphs are generated using open source software which I wrote, is publicly available, and has been looked at and used by lots of different people. This graph shows the actual measured temperature data for the United States Historical Climatology Network. It's known as the raw data set. This is basically a numerical average of all of the temperatures recorded each month averaged out over a year. This is not a perfect methodology because there's more stations in the eastern half of the United States than there are in the west, so the eastern stations get weighted more heavily. But the amount of bias produced by this simple numerical average is actually fairly small, and it's good enough for this analysis. Note that in the actual measured temperature data, last year was the coolest on record. The warmest year was 1934, and there's been a long-term cooling trend. Now let's look at the time of observation bias adjusted temperature. This adjustment turns the cooling trend into a warming trend. And next we will look at the final adjustment, which shows a strong warming trend. Remember that in the measured data set, 2019 was the coolest on record, but in the final adjusted data set, it's just about average. That requires some pretty dramatic data tampering to turn the coolest year on record into an average year. Now I'm going to show you an animation to show how the adjustments dramatically turn cooling into warming. Raw data set, TOBE, final. Raw data set, TOBE, final. The measured data shows a significant cooling trend, but the final adjusted data shows a strong warming trend, and this is the graph which gets released to the public. The public will never see graphs of the actual measured data unless they see it from me or from a few other people who present them. What the public sees are the graphs showing warming, and people generally assume that it's the actual thermometer data, but it isn't. These are the adjustments being made to the maximum temperature record. The red line is the time of observation bias adjustment. The yellow line is the final adjustment being made on top of the time of observation bias adjustment. The blue hockey stick shows the total adjustments being made in the final data set, about 2 degrees Fahrenheit. Let's look at these adjustments in more detail. First I'm going to focus on the time of observation bias adjustment, and later we'll look at the final adjustment. The time of observation bias adjustment cools temperatures from the 1930s about 0.7 degrees Fahrenheit, and more recent temperatures are cooled about 0.1 degrees Fahrenheit. The theory behind this adjustment is very simple. It's believed that back during the 1930s, most people reset their min-max thermometer during the afternoon, and this is potentially problematic. Suppose that you reset your min-max thermometer right here when it's 90 degrees Fahrenheit at 3 o'clock in the afternoon, and then the second day is much cooler. If we look at the 24-hour period between resetting the thermometer at 3 o'clock in the afternoon on day 1 and reading it on day 2, we can see that the highest temperature during that 24-hour period was 90 degrees Fahrenheit. What happens is the temperature for day 1 gets recorded as 90 degrees Fahrenheit and also for day 2, even though that is incorrect. We get double counting of hot days if the thermometer is reset in the afternoon. Ideally, the thermometer would be reset right at midnight and then we'd have accurate temperatures for both days. But the problem is that this was done manually and not many people are going to get up at midnight to reset their thermometer. In order to correct for this situation, NOAA does what's called a time of observation bias adjustment, which turns cooling into warming. This is a theoretical adjustment and it's difficult to prove one way or another whether it's correct. But there's a much better way to approach this problem. Instead of trying to correct the stations which reset their thermometers in the afternoon, the better approach is to simply eliminate them. Then they won't be part of the record and can't potentially corrupt it. So I did that experiment and removed all of the stations which reset their thermometer anywhere near the afternoon maximum. The red line in this graph shows only the set of stations which were reset in the morning or at night during July of 1936, and the blue line shows the trend for all stations. Note that the trend lines for both data sets are just about parallel and both are headed downwards. Also note that the shapes of the data sets are very similar with the same peaks and valleys. This tells me that the time of observation bias adjustments are probably incorrect. If we eliminate the suspect stations, the trend is still downwards. Yet in the adjusted data, the trend becomes upwards. I don't like the idea of attempting to adjust suspect data. The better approach is to simply eliminate it. The United States Historical Climatology Network has a lot of stations and we don't need to use all of them. You might wonder why the average temperature for the set of morning stations is higher than the average temperature for the set of all stations. This is because observers who reset their thermometers in the morning generally lived at warmer locations where they were more likely to go out to their thermometer and work on them in the morning. Observers who live in colder locations are more likely to reset their thermometers in the afternoon. And the afternoon stations are the ones that are eliminated from the red graph. Thus, the average temperature of the morning-only station data set is higher. In this graph, I compare the trend of the morning stations with the trend from the time of observation bias-adjusted temperatures. The morning stations show a cooling trend, and they're not subject to the issues which are used to justify the time of observation bias adjustments. The fact that there's a cooling trend in the non-suspect data tells me once again that the warming trend in the adjusted data is probably incorrect. Now we're going to look at the mysterious final adjustment, which is very poorly documented. The final adjustment turns a cooling trend in the measured data into a very strong warming trend. One of the justifications I've heard used for the final data adjustment is called changing station composition. The set of stations being used hasn't been completely consistent over time, so we could potentially get some effects caused by the fact that the set of stations being averaged 100 years ago is not exactly the same as the set of stations which are currently in use. Changing station composition needs to be taken into account. Once again, rather than attempting to adjust for this, the better thing to do is to use only a consistent set of stations, and that's what I did in this graph. The blue line shows the set of all stations, and the red line shows only stations which have a 100-year or longer temperature record. You can see that they both show a downwards trend, though the set of stations with a 100-year record has a slightly lower cooling trend than the set of all stations. This tells me that there's some validity to the changing station composition argument, though the magnitude of the effect is fairly small. But the total adjustment being made for the final data set is a huge hockey stick. So there's something else going on in these final adjustments, which, as I mentioned earlier, is very poorly documented. Here's one thing which I discovered 6 years ago, which I think explains most of the final adjustment. A lot of the stations being used are no longer reporting every single month. When a station doesn't report, NOAA fabricates data for that station for that month using a computer model. During the 1970s, only about 10% of the data is fabricated, but last year was all the way up to 42%, which means that 42% of the data being used in the final dataset is essentially fake. Since almost half of the data in the final dataset is currently being fabricated, NOAA can produce pretty much any shape graph that they want. In this graph, I show the temperatures being used in the final dataset from the fabricated data only. You can see that the fabricated data shows a massive warming trend since the 1970s of about 4 degrees Fahrenheit. But if we look at only the measured adjusted data for the same time period, it shows half as much warming of about 2 degrees. This graph shows a difference in temperature between the final fabricated stations and the final measured adjusted stations. You can see how last year the fabricated stations were 3 degrees warmer than the adjusted actually measured stations. NOAA is using some pretty dramatic fake data. And remember that in the measured data set last year was the coolest on record. But in the final data set last year was just about average temperature. It looks to me like this was accomplished by throwing in huge amounts of fabricated and very warm data. My conclusion is that the adjustments being made in the final data set, which produce a strong warming trend, are almost entirely bogus. From my 12 years of studying this, I believe that the measured data showing a cooling trend in afternoon temperatures is probably accurate. Supporting the idea of long-term cooling in the United States are these graphs from the National Climate Assessment. These graphs show that the United States used to be much hotter than it is now. NOAA makes this cooling trend disappear by creating lots of recent fake data, but I don't accept their adjustments. I don't think they're legitimate. NOAA has never been transparent about what they're doing, and they need to be pressed into explaining why they're turning a long-term cooling trend into a warming trend. The accuracy of NOAA graphs is critically important for public policy makers, and we need to get to the bottom of this. Toto's been studying this for the past 12 years. You can visit him and Kyrie on the web at realclimatescience.com.